Brand new chapter, brand new marking period, brand new start for some of you guys, okay? So we had a big talk about this the other day. I'm not going to talk about that anymore, but let's do our best. This is a great place to start changing your ways. For some of you guys are doing great, so keep it up. Keep doing what you've been doing, all right? Some of you guys haven't been doing so good or not as well as you want to do. Then you got to change some things. You got to do things. Hey, you got to do some things that are different. You can't just expect to do the same thing and expect a different result. You've got to change something, all right? So now's a good place to start. I think you'll like this chapter a little bit better than what we did in the last chapter, I hope. So here we go. I don't know if it's easier or harder. I don't know. It's a fresh start. That's all that counts, right? So we're going to talk about angles. We've already talked about angles. We really haven't talked about triangles too much. I think we described, if we have three sides, it's a polygon and it's a triangle. We did that, but we really haven't done like much at all with triangles. But this is the chapter. Really, from now on out, we're going to be dealing with a lot of triangles. So this is where you start learning about it. There's basically three types of triangles that we're going to talk about for right now anyway. Three types of triangles. And we're going to deal with, and I'm going to put this in not a quotation mark, but a parentheses, and we are going to talk about the angles. We're going to describe these triangles by their angles. All right? So I got three types of triangles. Then I got another three types of triangles, and we're going to classify them by their sides, what kind of sides they have, all right? But right now, these three types are just by the angles. So here's the first one. And let's tell you what, I'll just draw it right here. So try to draw it so it looks something like mine. All right? Again, I'm just looking at the angles. Let's take a look at these angles. Look at this angle down here of this triangle. Look at this one and look at this one. What does it look? Now, we have discussed this before, okay? What does it look like all three of those angles are? What type of angles? Acute angles, very good. All right, they're all acute angles. So if you have, let's raise this up a little bit so I can write below it. If you have three acute angles in a triangle, I'm going to do the angle symbol. You've seen that before, haven't you? Yeah, the angle symbol. If I have three acute angles, then guess what I'm going to name this triangle? Yeah, we'll call it an acute triangle. I don't think I've shown you this before, but here's a little symbol for triangle. It looks like a triangle, okay? But it's not just any old triangle. It looks like that style of triangle. We'll talk about what that style is a little bit later. All right, so we call this an acute triangle. How do I know it's an acute triangle? Because if I look at all three angles are acute angles. What does that mean to be an acute angle? Say it, Tyler. Less than 90 degrees. Very good, okay? If your angle is less than 90 degrees, it's considered to be an acute angle. Everybody with me on that? Okay. Let's do another one. I'm going to draw this one. It's still a triangle, but it's going to look a little bit different. Yeah, we'll do this one. I was going to do a different one, but we'll do this one. All right. And I'm going to put a little box right there. We've talked about that before. What's that little box? What does that indicate is true about that angle? It's a right angle. And how many degrees is a right angle?
90.
It's 90 degrees. Very good. See, isn't it fun to know stuff? It is. All right. Now, how many right angles are in this triangle? Just one. Could I have a triangle with more than one right angle? Because if I tried, watch this. Well, not necessarily. But watch. What if I drew, look, here's a right angle. Everybody with me on that? So if I tried to draw another right angle, I could draw it from here, or I could draw it from here. Would you agree? So let's draw it from here. That's a right angle. You could go all the way to there, or you could go here, or you could go up there, right? Would you agree? But is there any way that that's going to be a triangle? No, there's no way, because there's three sides. Is there any way that they come together? The only way they come together is if you did that, and now that's not a right angle over there anymore, is it? So I cannot have more than one right angle. I can only have one right angle in a triangle. I could have a rectangle with more than one right angle. I could have other things with more than one right angle, other things we're going to talk about later, but I cannot have a triangle with more than one right angle. So this has one, I'll simplify right, or shorten it to RT, is that all right? So one right angle. And again, that's 90 degrees. So take a wild guess what we're going to call that triangle. It's a right, it's not a right angle, it's a what? Right triangle. Right, it's a triangle. So I call it a right triangle. Pretty easy so far, isn't it? Yeah. I mean, the beginning of the first chapter, or the first chapter that we always do, usually is a little bit easy, but I'm going to scooch this over a little bit right there. All right, that's pretty good. We're going to talk more about the other angle. Let's talk about this right now. Take a look at this angle right here and this angle right there. What does it look like is true about those two angles? They're acute angles, okay? How many are there? There's two. Does that make it an acute triangle? How many acute angles do you need to make it an acute triangle? All three of them have to be acute. Just because you have two of them does not mean that it's an acute triangle. All three have to be acute for it to be an acute triangle. Everybody good? All right, let's do one more. And again, we're classifying these by their what? By their angles. I'm only talking about the angles. Have I talked about the sides at all? No, I haven't even talked about the sides at all. We're going to do that next. So did that just go? It sure did. Why did it do that? Let me pause the recording because the dumb old projector went blank on me here. Okay, looks like we're back in business. All right, here we go. Guys, just because I stop for about 2 seconds doesn't mean you just can do whatever you want. Let's pay attention. All right, let's do another triangle. And you may already know what this is going to be, but we're going to do it anyway. All right, so we had three acute angles. We had one right angle. And what do you see that's different about this compared to the other two? You got this angle right there. What is that angle? It's obtuse. Again, can you have more than one obtuse angle? No, you can't. And we're going to figure out, I don't know, maybe today. Yeah, today we will figure out, like mathematically, why you cannot have more than one obtuse angle or more than one right angle. But we haven't mentioned it just yet, so we'll get to it. Anyway, so what do we got? We got one obtuse. What does that mean to be an obtuse angle? That's it. If it's greater than 90 degrees, it's considered to be an obtuse angle. So if you have one obtuse angle, guess what we're calling this triangle? An obtuse triangle. All right, very good. All right, let's keep going. Everybody got that down? I'm going to scooch it up a little bit. So those are three types of triangles according to their angles. Now what I'm going to do are three types of triangles according to their sides, to their sides. All right, so let's write that down. So three types of triangles. Do you mind if I put that for triangles instead of writing out the whole thing? Yeah. According to their sides. All right, the first one is a word maybe you have, maybe you haven't heard it before. I don't know. Let's see, did we talk about? No, it was another thing I was thinking of. Here's a word. We don't use it very often, but again, we're looking at the sides. I don't care about the angles. I just care about the sides. Everybody hear me? Yeah. Look at all three of these sides. Do you see anything like in common or not in common about these three sides?
None of them are congruent.
Yeah, none of them are equal to each other. None of them are the same. None of them are congruent, like Cameron said. All right, so watch. I'm going to put one tick mark here. Remember this, right? If you have two things that have a tick mark on it, it means they're equal to each other. Yeah. But that has one tick mark. We'll put 2 for this. We'll put 3 for this. What does that automatically tell you about those three sides? That they're different. They're not congruent, okay? It's completely opposite than they're congruent. If they were all congruent, each one would have just one tick mark. okay? If they all have different number of tick marks, it means they're all different, okay? They're unequal. They're not equal to each other. Everybody got that? All right, so this means none of those sides. So no equal sides. So if you have a triangle and none of the sides are equal, we have a name for that. It's a weird name. Again, we don't refer to this name very often, but here it is. We call it a scalene triangle. Have you ever heard of that?
No.
Probably not. It's probably something you haven't heard until you get to geometry. But that's what it is. It's a scalene triangle. Again, we're not going to do a whole lot with scalene triangles, so let's just move on to the next one. Is that all right? So this one, I'll tell you what, I'm going to use this. And I'm going to make a triangle. There we go. But I'm going to stretch it out a little bit like this. All right? So here's a triangle. Now, it kind of looks like one of the, well, it doesn't look exactly like it, but you could, if I was going to just talk about the angles, what kind of triangle is this according to the angles? It looks like an acute triangle, but I'm not trying to classify it by its angles this time. I'm trying to classify it by its what? Sides. Now, what does it look like, just glancing at it, what does it look like might be true about some of the sides here? Yeah, it looks like this side and this side are equal, doesn't it? If they are equal, then I'll put one tick mark for one, then I'll put one tick mark for the other. So all the sides with one mark, one tick mark, means that they're equal to each other. Makes sense, doesn't it? Right? I don't have to put anything there. I know I got two sides equal. So here's what this says. Now, technically, it's this. If you have a triangle with at least two equal sides, now that at least means, we'll talk about that in a second. So if you have at least two equal sides, do we have at least two equal sides on this? Yeah. Then we call this, and I would venture to guess that you've probably heard this word before. Now, the spelling of the word, let's get the spelling down right now, okay? I don't mark off for spelling, but if you try to give me a word and it's so crazy, ridiculously badly spelled, I might mark off for it if I can't even tell what the word's supposed to be. But here's the word. Everybody ready? It's called isosceles. Have you ever heard of that? Yeah. So here's how we start it. Isos. Everybody see that? That's easy. I-S-O-S. Everybody say that. Isos.
Isos.
Right. And then celes. C-E-L-E-S. It's got two words, right? Isos and then celes. The S and the C are next to each other. It's a hard word to spell sometimes, but if you break it down into these two, it's easy. You ever hear the singer Celine Dion? You ever hear her? Yeah, she's kind of older now, and she's not that popular. Back in the day, she was crazy popular. How does she spell her name? She spelled her name with a C. Well, Selena, we got our own Selena in here, okay? We have a Selena. She spells it with a C, C-E-L, all right? So think of that. Isos, and then what? Celes, C-E-L-E-S, all right? Let's make sure we spell it correctly. Can you make an effort to spell it correctly? Yeah, I'm a big fan of spelling things right. Say that again. Right, but it's isos. That's easy. Isos. Okay. Think of two words. Isos. I-S-O-S. Right. Everybody got that? Yeah, that's easy. And then celes. That's the hardest part. But it starts with a C. C-E-L-E-S. All right. So let's spell it correctly. All right. And I know as much as I could do this, I could give you spelling tests on this every day, and then it comes to the quiz and you're gonna spell it wrong. All right. But try to spell it right. All right. I have never seen an abbreviation for isosceles. But it's an important word. Let's listen. Hey, let's not get off track. Isosceles is a very, very important triangle in geometry. We talk about it quite a bit. All right, this is not an obscure word that we hardly ever use. An isosceles triangle is something that we talk about a lot. All right, scalene triangle, not so much. Isosceles, definitely. We definitely talk about isosceles quite a bit. So make sure you know what that is. Now, it says at least two of the sides are equal, which means you could have what? You could have an isosceles triangle with three sides, because if it says at least, that means two or more, right? Isn't that what at least means? Yeah. So I could have a triangle. Let's click on this again. Yep. Watch this. What if I had a triangle like this? What does it look like just to your eye is true about the sides of this triangle? It looks like now the sides can't be acute. What can only be acute? The angles. Or you could have an acute, what? Triangle, but you have an acute triangle because the angles are acute. You can't have acute sides. Everybody hear me? Yeah. Sides cannot be acute, but they can be equal or congruent. I'll use equal and congruent interchangeably, all right? But these three sides could be equal to each other. I'll tell you what, let's put 2 marks. So if they're all the same, if this has 2 marks, 2 tick marks, how many should this have? 2. And this should have 2. Everybody see that? That means all 3 sides are equal. Why did I use 2 here instead of just 1? Well, because on this one I already used the 1, okay? But you could have done that before. All right, so check this out. If you have a triangle with all 3 sides, technically you could call this an isosceles triangle. Why? Because at least 2 of the sides are equal. But I'll tell you this, almost all the time, Nineveh is where? I think behind Christina. Is that where she was? Yeah. Okay. So most of the time we reserve isosceles when you only have 2 sides that are equal. Okay, technically the definition is at least 2 sides, so I could call this one isosceles as well. That would be okay. I would give you credit. If I asked you, what kind of triangle is this according to its sides, and you said isosceles, yeah, I would give you credit. But most of the time in geometry, when we talk about an isosceles triangle, we're talking about triangles that have exactly 2 sides equal to each other. You hear me on that? That's not really the definition. But most of the time, when we refer to an isosceles triangle, we're thinking of triangles just with 2 sides equal and not 3. Okay? Now, this one has its own word to this. So, all 3 sides. So, I'll say 3 sides are equal. So, if all 3 sides are equal to each other, then I call this, everybody watch, it's called an equi, E-Q-U-I, and then it's lateral. Lateral means sides. This is the third one. Yeah, I didn't put a 3, but yes. All right. So I've got a scalene, none of the sides are equal. Isosceles, 2 of the sides are equal. Equilateral, again, this might be a word that messes us up a little bit, but it's really not that hard. Look, equi, E-Q-U-I. All right. That means what? What do you think that means? Equal, right. And then lateral, what did I just say a second ago? What does lateral mean? Anybody play basketball? Yeah. You do this drill. And maybe other sports you do as well, but I know in basketball we used to do this drill all the time. They'd hold the ball up, the coach would have the whistle, and then he'd move the ball to this side, and what would you do? It's like a defensive drill. Anybody know? You like shuffle your feet, right? You move your feet back and forth like this, and you go to one side, you blow the whistle, you move the ball over here, and you go to this way. They call that the lateral drill, all right? You move side to side. You guys listening? You move side to side. So lateral means what? Sides, okay? That's what I think of. If you've never done that drill and nobody told you the name of it was a lateral drill, then it doesn't help too much, all right? But lateral means the sides. So equal what? Sides. Got it? Now, I'm going to add a 4th to that first one that we did. Okay? So I had acute angles, I had a right angle, I had an obtuse angle. This is kind of like, I don't know, it's not exactly one of the big 3, it's like a little subcategory, but I'll do it right here. If you look at all 3 of these angles, look at this angle right there, and look at this angle right here, and look at this angle right here. What does it look like might be true about all 3 of those angles? It looks like they're all equal too. So I could call this equilateral because the sides are equal, but I could also call it equiangular. Very good. I could call it equiangular. So that's equilateral. Why? Because all 3 sides are equal. Equiangular triangle means what? All 3 angles are equal to each other. Make sense? Equilateral is sides, equiangular are angles. Equiangular, right? Makes sense, doesn't it? Angular, angles, sure. So if it's, and this is something I don't know if they talk about it in this lesson or not. Let me just take a quick peek. I don't think they do. Yeah, it doesn't look like they do. Probably another lesson we'll talk about it, but I'll give you a little sneak preview. If you have a triangle that's equilateral, that automatically means it's also equiangular. You hear me on that? So if all three sides are equal to each other, that automatically means all three angles are going to be equal to each other. We'll talk more about that as we go a little bit further. But that's just something kind of interesting to know about this. All right, so if it's equilateral, that means what? It's equiangular. Everybody got it? Okay, let's move on. This next thing's kind of interesting, I think. This is something I wanted to talk about when we first did this. Remember I said you couldn't have any more than one right angle or one obtuse angle? There's a mathematical reason for it. I'm going to show you right now. Let me grab a piece of paper. Which one's your friend? Is that your friend with the red? Or is it the other one? Is that your... Alright. You won't be able to see this on YouTube, but that's okay. Yeah, not everybody's here today, but what I'm going to do... Oh, grab me those scissors right there, Tyler. Blue handles. I'm just going to make a triangle out of this. I mean, I could make any kind of triangle. It's Monday, of course. You can't be in class on Monday. Watch this, what I'm going to do first before you leave, okay? I think it's kind of cool. I just made a triangle. Oh, watch this before you leave. Watch this before you leave. Don't leave. Okay. Here's a triangle. Would you agree? Yeah. It's a right triangle because it's a corner of a piece of paper, but it doesn't matter. Watch what I'm going to do. Molly, where are you going? Watch. I'm gonna rip off this angle. Okay. I'm gonna rip off this angle. Okay, and I'm gonna rip off this angle. Now, when I made the triangle, I mean, I knew I had a right angle, but it doesn't matter. I can make any triangle I want. Okay. These are the three angles of my triangle. Would you agree? Okay, now watch this. If I put them together like this and like that, what did I just form? It's not a triangle. No, it's not a triangle. What's on, like up top? No, forget the bottom of it. Look, it's a straight line. It's a straight line. Look, all those angles form a straight line, don't they? What do I know? Listen to me. I know this is exciting, but watch. What do I know about a straight line? It's 180 degrees. So watch. This angle plus this angle plus this angle, what do they add up to be? 180 degrees. You guys can go. All right. Wasn't that cool? Wow, I get an applause and everything. Okay, so check this out. So watch. We'll call this angle A. We'll call this angle B, and we'll call this angle C. Everybody with me? Hey, look up here. Look up here. I know it's hard to calm down from all that excitement, but I actually thought it was a triangle. It was. You thought it was going to be a triangle? So tell me something about angle A plus angle B plus angle C.
They equal 180.
That's it. It equals 180 degrees. That's probably something that you've heard before. Have you heard that before? No. You had a triangle, if you add up all, you've never heard that all three angles add up to 180? No. Nobody? Okay, it seems like that's something that was probably taught in middle school somewhere. My guess is, I might be wrong, my guess is the teachers probably didn't really show you why they add up to 180. I think that little trick's kind of cool. I do that every year. I teach this, and it seems like everybody likes that. But that means that, watch, this angle plus this angle plus this angle. It doesn't matter the shape of the triangle. It could be equilateral, it could be obtuse, it could be acute, it could be scalene, it could be isosceles, it could be equilateral. It does not matter. Any triangle at all, if you add up the three angles, it's always going to be what? 180 degrees. Everybody good with that? There's something else I could show you with that up here, but I'm not going to just because of time. I gave myself 2 days for this lesson anyway, so I don't need to completely rush. But let's take what we just learned right here and what we learned about a right triangle and talk about that for a minute. All right, so let's draw a right triangle. Okay, and put a little box right there. That's a right triangle. Why is it a right triangle? What do all three of these angles add up to be? We'll call this angle A, we'll call this B, we'll call this C. Is that all right? So what do I know about angle B? It's 90 degrees. Correct? Now watch this. What do I know about angle A plus angle B plus angle C? What do they all add up to be? 180. I know that this is a right angle because I drew a right triangle, correct? So what can I do here? I can replace that angle B with what? A 90, that's right. Because angle B is 90 degrees, I just replace that. So what I want to do is I want to see what is the relationship between AC and the whole thing. So look, I'm going to do a little quick algebra. Everybody watching? Let's subtract 90 from both sides. So what do I have? I got angle A plus what? Angle C. What does that equal? 90 degrees. So here's the important part. I did all that to show you this. These are acute angles. We did talk about that before, right? I said the other two angles will always be acute angles. The acute angles of a right triangle add up to what? 90 degrees. All right, so any right triangle, the other two angles, not the 90-degree one, but the other two angles will always, every single time, add up to 90 degrees. And that's something that we need to understand because you're going to do some problems where you have to add up those two angles, set them equal to 90, and then you might have to solve for angle A or angle C or something like that. So it's super important that you understand that when you have a right triangle, this angle here and this angle here will always add up to 90 degrees. We have a thing called a, actually, let me see. This thing right here was called the triangle, let me see, what did we call it? Angle sum theorem. The triangle angle sum, and then we use this word theorem. Use that a lot in geometry. It's basically like a rule. It's a law. Somebody said law earlier. It's kind of like a law. That's what the word theorem means. But it can be proven. And we kind of proved it with ripping off the angles of the piece of paper, right? There's another way to prove it. I could do that, but again, I'm running out of time, so I'm not going to do that right now. But this is called the triangle angle sum theorem. What does that say? It says that all three angles of a triangle add up to 180. Or we could say it like this. The sum, what does that mean, the sum of something? When you add them up. The sum of the angles of a triangle equal 180 degrees, okay? This is kind of like an offshoot of that, isn't it? Got a right triangle. I talked about all these adding up to 180. This is kind of like an offshoot of that theorem. When you have something that deals with the theorem directly, we call this a corollary. It's probably a word you haven't heard before. Okay, it's called a corollary. It's the same type of thing as a theorem, but it's just like a sub-theorem, right? It has to do with that major theorem, but it's its own little theorem that has to do with the angles adding up to 180. So here's what this says. It says that the acute angles of a right triangle, what do? They add up to what? To 90 degrees. We had a word supplementary before. What did that word supplementary mean? 180. Supplementary means they add up to 180. We have another word and we've mentioned it a couple times, not a whole lot, not near as much as supplementary. But there's a word that talks about angles adding up to 90 degrees. Does anybody remember that word? Nope. I can see why you would say that, but that's not what it is. It's complementary. Complementary. Spell it right. Complementary. Okay, so what does complementary mean? They do what? They add up to 90. Everybody see that? A corollary. Okay. A corollary is just another word for a theorem. Okay, it's just like a little mini theorem. It's a theorem that has something to do with the big theorem. What's the big theorem? The big theorem says that all the angles add up to 180. Okay, the corollary, or the little sub-theorem, right, that kind of goes underneath of it, it says that the acute angles of a right triangle are complementary. So it means that A and C equal 90. That's basically what that says right there. You still following me? Is it as easy as when you first started with an acute triangle? Well, you knew it was going to be like that, didn't you? All right, let's do an example, and then I think we'll quit, and then I'll let you do some problems. We're not done the lesson. Got more to do tomorrow, but at least we're here. Actually, it's not really an example. It's another corollary. Again, it has to do with that first theorem that we dealt with, right? That all the angles add up to 180. This one says this. So let's draw this again. What did I say this triangle was? Okay. And if it's equilateral, it must also be what? Equiangular, right? So that means all three angles all three angles are equal to each other, right? Now watch this. Everybody watching? We're almost done. I can see some of you guys fading out. So let's pay attention. Let's stay focused. So I don't know what that angle is. Well, actually, I do, but I'm gonna prove it to you. All right, I'm gonna show you what that angle is actually equal to. If I know that's equiangular, I know exactly what that angle is right off the top of my head. It's not because I'm super smart. It's because I did this. Watch this. If this is x degrees, and if all three angles are the same, what would this angle be called? X degrees. What would this one be called? X degrees. Now, what do we know about all three angles of a triangle? What do they do? So x plus x plus x, those are all three angles added up together, correct? What do they add up to be? 180. Have you figured this out yet? So what's x plus x plus x? 3x equals what? 180. Let's solve for x. Divide by 3. So what's x equal to? 60 degrees. It doesn't matter how big, how small your triangle is, each angle of an equilateral or equiangular triangle will always be 60 degrees. Check this out. I'm going to copy and paste this, and I'm just going to make it smaller. Is that all right? Now, the sides are different, obviously, right? It's a lot smaller. But check this out. What if I put this angle up here? Just because I made that triangle smaller, look at that angle.
Students, JV cheerleaders were dismissed at 2:40 today. Thank you.
Do you see that right there? Okay, that's still, what's that top angle then? 60 degrees, right? And if I can grab it, come on. There we go. Look at that bottom left angle. See, it matches up, doesn't it? It doesn't matter how big or small I make the triangle. If it's equilateral, it's going to be equiangular, which means what? All three angles will equal 60 degrees. So that can come in handy. There's a lot of problems they're going to ask where you have to know that all three angles add up to 180. There's problems where you have to know that the acute angles of a right triangle add up to 90 degrees. There's problems that you're going to have to know how to do. They're going to give you an equilateral triangle, and you're going to have to find what the angles are. And again, Now you know off the top of your head how many degrees that angle is, don't you? And it wasn't that hard to figure out, was it? This is kind of like a proof. It basically is. So the theorem says that each angle, this will be the last thing, each angle in an equiangular triangle equals 60 degrees. And that's what the corollary, it's a theorem, it's a rule, it's a law kind of thing, all right? But it's one that you can prove, and we did prove it. We kind of proved this one, kind of, all right? And then we proved this one as well. No, we did prove that one, all right? And we proved this one, so that's cool. Those are proofs, and that's what you do in geometry a lot. All right, we will stop right there, but I want to give you what the assignment is. Now, you may not be able to do a whole lot of these problems, but I think there are several that you should be able to do. So, again, this whole thing is not officially assigned, but I will assign some of it. So this is section 4.1 and pages. Now, I don't know what number you should be able to get done on this, but do as many of these as you can. Okay? Is that what I put on the lesson plan things for you? Did anybody look? Let me, oh, I don't have it. I didn't print it out yet. Let me see. Yeah, 1 to 16, and then tomorrow we're going to do 21 to 29. So you should be able to do most of these, maybe all of them. I don't know. I don't have the book out in front of me, but you should be able to do quite a few of these, if not all of them. All right? We'll see. See what you can do. Everybody good? You got 15 minutes, okay? Some of you guys asked me, remember we talked Thursday and you said, can you give us more time to work in class? Now you got it. You got 15 minutes. So don't just put everything away and say, I'm just going to sit around and wait until school's over. You got 15 minutes. Let's get started right now and see how many you can do. All right.